Okay, so the inner core, that's this guy right through here. Okay, that's your inner core. Think of it like taking apart a baseball. It's that core in the middle of baseball. A couple things that you guys need to know about the inner core, right, Hannah?
Yeah.
Okay. So a couple things to know about the inner core. It is completely solid. We'll talk about how we know this to be true later. We do know that it is completely solid. And it basically makes up 25% of the radius, so it makes about a 1,000-mile radius of the core. And basically we have 80-20. 80% iron, 20% nickel. So pretty dense stuff. And the other thing you need to know is that it basically radiates a lot of heat outward. You give a lot of pressure. With pressure, you have heat. Pressure and heat are directly proportional, which means as one increases, so does the other. When you increase the temperature, you increase the pressure. That's why high pressure days are really good days in terms of weather. We get warmer weather with high pressure days. Higher the pressure, the higher the temperature. And vice versa. If we increase the temperature, we're increasing the amount of pressure that's being exerted. So we get a lot of pressure coming out of here. We get a lot of heat, and tremendous amounts of heat. If you want to put it in perspective, as you move towards the crust, what happens to the temperature? Move out. No. So as we move outward towards the crust, it actually starts to cool, right? So think about volcanoes when they erupt and they have the lava coming out on the surface. That's pretty hot. Okay? Well, that's at the surface. Now imagine that all the way at the core. So very, very, very hot. Extremely hot. Tremendous amounts of pressure. Okay? By the way, how do we know that it's 80% iron? How do we know it's solid? How do we know this stuff? I'm going to pose a question to you, and I want you guys to think about it for a minute. My question for you is very simple. What is the connection between meteorites and the core of the Earth? I want you guys to take a minute, and I want you to think about that. Rock that has all these different layers in it. Let's kind of get this here going, see if I can get a whole drawing for you guys. So we have all these layers, little brown layers here, and then those other colors. Just to kind of prove our point here. So we have all these layers that are surrounding the outer edge of the meteorite, right? And then that inside, solid what? That's your iron. Well, when this comes into the atmosphere, what starts happening to those outer layers? They burn off. So we come in contact with our atmosphere, and all of a sudden this front edge starts to burn off. And eventually, all that's left over is this tiny remainder of the core of that meteorite. So what we actually pick up is the core of the meteorite. In our understanding of how the universe is made, and understanding that planets are basically a bunch of meteorites that collide together and fuse together, we make this deduction that basically the inner core of the Earth is very similar to that of the meteorites. It's completely solid iron. So you have 80% iron and 20% nickel. And that's where we get this idea of, that's how we know that the core is solid. Now, we didn't get that verified until the late 1960s with seismic data. That's a whole other issue to talk about. Okay? I want to make sure you guys understood that connection between meteorites and the inner core, because we will be talking about that in the homework tonight, and you will need to know that for your test.